you're seeing here is a map. We're going to drill locations at random into a reservoir and display on this map what we encounter in terms of porosity. And with each sample, we get either a 0 or 100% porosity. We only get one sample per well. So it's going to be 0 or 100%. And I'm going to ask you, based on the samples that we obtain, what the porosity structure is in the underlying reservoir. And then we'll take a look at it and see what that reservoir looks like. So here we go. I've just drilled the first well here, and I've hit 0% porosity in this well. And you can see in the legend, the black circles are 0% porosity, and the white circles show 100% porosity. So well number 2 shows 100% porosity in the reservoir. So let's go on and drill a number of different wells here. Again, they're just randomly placed throughout our area. Most of the wells, as you see, are coming up with 0% porosity. There are only a few with 100%. Okay, now I've added these wells stepwise, and here you have it. This is the total field of our sampling. What's the pattern? Do you see what the porosity structure is that's underlying this? This is where you get your chance to try to think this through. Maybe while you're thinking about it, you might think about what is the magnitude of the porosity. That's an awfully easier question, I think. But really the question that you're faced with is, what is the structure that I've sampled with all these, quote, wells, unquote? Okay, I'm going to move on now. If you're not ready to see the answer yet, hit the pause button and think about that question on the porosity structure. But I will, in the meantime, be moving on right now, and we'll take a look and see. We'll remove the surface, mine down below the surface, and see what I've actually sampled. Now, what we're looking at here is a map view of an aerial photograph of a horizontal sandstone layer, and it has a fracture system in it. And if this is what you were expecting in terms of the sampling that I'm doing here, then you were wrong, because this is not at all the basis of the exercise. I added this picture later on, and in order to just remind us all that ultimately what we're looking for is characterizing a natural fracture system. However, the real basis for this exercise is shown here. And what you're looking at here is a thin section photomicrograph of a sandstone. You can see the scale at the bottom, a millimeter. The white features are quartz grains, and the reddish brown are lithic fragments. The blue is blue epoxy, which has been impregnated into the sandstone. So everything you see in blue is porosity, actually. So that's where I've gone in and done my sampling. And you can see that the wells that I've drilled in here that are shown with the black circles have hit quartz grains or lithic fragments, and the white circles have come in and hit the blue epoxy areas. So that's what's defining 0 or 100% porosity. My point in doing this is to say that heterogeneity is scale dependent. We're looking at a much different scale here. And if I were to zoom out and not be looking at 1 millimeter on the scale, but tens of meters on the scale, this particular rock, the porosity system, the matrix porosity in this rock, would be very homogeneous or trending toward homogeneity. Whereas if we looked at a fracture system at the scale of a few meters, we're nowhere near homogeneity yet. It would be very heterogeneous still.